Bernoulli's principle. The flow of a fluid is streamlined if every particle of the fluid flows exactly the path of its preceding particle and has the same velocity as that of its preceding particle. Consider a fluid moves through a tube of area of cross-section A1 and A2 respectively. The volume of water entering A1 per second and the volume of water leaving A2 per second. Therefore, mass of liquid entering per second at A1 and mass of liquid leaving per second at A2. Assuming there is no loss of fluid in tube, that each for ideal fluid therefore, or AV equals constant. This is the equation of continuity. When fluid flowing through a section of pipe with one end having a smaller cross-sectional area than the pipe at the other end, the velocity of the fluid in the constricted end must be greater than the velocity at the larger end. Bernoulli's equation applies conservation of energy to formalize this observation. Consider a tube AB of varying cross-section A1 and A2 and at different heights H1 and H2. Liquid is flowing from A to B. P1 is greater than P2. Here, A1 is greater than A2. So, V1 is less than V2. The force on the liquid at A and at B. Now, the work done per second on the liquid at section A and at section B, V1 equals V2 equals V. Equation of continuity. Net work done equals P1V minus P2V. The net work done per second is equals increases the potential energy and kinetic energy per second from A to B. According to law of conservation of energy,